This video is on calculating limits using limit laws, part 1. So here we have the limit laws. So here's the first one, which is the limit of f of x plus g of x as x approaches a is equal to the limit of f of x as x approaches a plus the limit of g of x as x approaches a. All this is saying is that you could just do these individually and then add them together. So you can take the limit of the first one, which is this one, and then take the limit of g of x and then just add them together. Pretty much the same thing for this one right here, which is the limit of f of x minus g of x as x approaches a. You can do that individually as well. So you can just split it up. You can take this one, put it over here, take the limit of that, then take the limit of g of x individually, and then just subtract them. Then there's the limit of f of x times g of x as x approaches a. And that one, again, you can just split it up by doing the limit of f of x first, then doing the limit of g of x, and then just multiplying them together. In division, you could do the same thing again. So you're just going to take the limit of the f of x first, then take the limit of the g of x, and then you could divide them, so long as g of x is not equal to 0. And then you have another law which deals with constants. So if you're taking the limit of some constant times some function as x approaches a, what you could do is you could just take the constant out, which is what I did here, and then you can just take the limit of the f of x and then multiply it by the constant. So let's get a little bit of experience with these. Let's do a couple problems. So here I have the function f of x, which is blue, and another function which is g of x in red. So first let's use the addition law. So here's the limit of f of x plus g of x as x approaches 0. So this can be split up. You can split this up by doing the limit as x approaches 0 of f of x plus the limit of g of x as x approaches 0. Now since we split this up, now I can take the limit of this by itself. So here's f of x, and as f of x approaches 0 from both sides, it gets a value of 1. So this is 1. Now the limit of g of x as x approaches 0. So here's g of x. It's coming here from the left, and from the right it's coming to the same point to 0. So that's 0. So this is plus 0. So the answer to this is equal to 1. So now let's do the multiplication rule. So the limit of f of x times g of x as the x approaches 0. So again, we can split these up, and it'll be the limit of f of x as x approaches 0 times the limit of g of x as x approaches 0. So I know what the limit of this is because we just calculated it. So that's going to be a 1, and that's going to be a 0. So 1 times 0 is equal to 0. So now let's try the subtraction rule. And again, you just split these up. You can say the limit of f of x as x approaches 0 minus the limit of g of x as x approaches 0. So we already know what the limit of these are because we already did it. So the limit of f of x as x approaches 0 is 1, and the limit of g of x as x approaches 0 is 0. So 1 minus 0 is equal to 1. So now let's use the division rule. So now here the limit of f of x divided by g of x as x approaches negative 1. So we're going to split this up. So we're going to say the limit of f of x as x approaches negative 1 divided by the limit of g of x, let me scroll down, as x approaches negative 1. So let's see, where would that be? We're approaching negative 1. So as f of x approaches negative 1, it's going to come to right here. So that's about a half. And as g of x approaches negative 1, it comes also to a half. So this one's going to be, so that is, let's see, so the limit of f of x as x approaches negative 1 is equal to 1 half. And the limit of g of x as x approaches negative 1 is also equal to 1 half. So this is equal to 1. So now let's use the constant rule. So the limit of some constant 8 times f of x as x approaches 0. So here we can take the 8 out and say the limit of f of x as x approaches 0. And from previously I know that this is 1, but let's just check it out. So here's f of x as it approaches 0, it's 1. So I can replace this limit of f of x as x approaches 0 as 1, so it's 8 times 1, and that's going to be equal to 8. So that's how you do those problems. I hope these problems made sense to you. If not, there's another tutorial I made that explains everything about how to do limits. This is on calculating limits. So I hope it made sense. If it did, great. And I hope you enjoyed the video.